Everyone, and welcome back to another calculus video. In this video, we're going to talk about optimization. So, keywords to know you're trying to optimize a problem would be maximize or minimize. I'm not sure why that's writing so big. Let me see if I can fix that. So, we're looking for those keywords. I want to maximize profit, or I want to um, minimize perimeter because I want something of a certain size. So how do we go about doing that? Well, we've got to figure out some equations that's going to tie everything together. And then we're going to use calculus to do that. Once we come up with those equations, we're going to take derivative. Maximize or minimize means we're going to have to take a derivative. And the reason we want to take the derivative is because we want to maximize something. And the derivative, if we set it equal to 0, we'll find critical numbers to help us figure out if we have a maximum or a minimum value. And then we can use that first derivative test to conclude that, or the second derivative test. So let's look at an example. Number 15. We want to find the dimensions of a rectangle with an area of 200 square feet that has a minimum perimeter. So that's our keywords to let us know we want to optimize. So here's my rectangle, length and width, and it doesn't matter which side you call length and which side you call width. Area is length times width, and we know the area is going to be 200. And we want to minimize the perimeter, and the perimeter is the distance around, which would be 2 times L plus 2 times W. The problem with taking the derivative here is that we've got too many variables. So this is where that area equation is going to come in handy because we can solve it for one of the variables. I'm going to solve for W, and then we can substitute that in. So if I substitute that in, my perimeter equation is now 2L plus 2 times W, which is 200 over L. So I'm going to clean this up. So this is 2L plus 400 over L, which is the same thing as L to the negative 1. So I'm going to rewrite that to make it easier to take a derivative. It is not necessary in this case to use a quotient rule. So let's take the derivative. The derivative of 2L is going to be 2. And if I take the derivative of 400L to the negative 1, I'm going to bring that exponent down, multiply it by the constant in front. And I'm going to take the derivative, I'm going to subtract 1 from the exponent. So there's my derivative. Now we're going to set that derivative equal to 0. This is going to find critical numbers. So 0 equals 2 minus 400 divided by L squared. So I'm going to move this term to the other side. I'm going to multiply both sides by L squared. Divide both sides by 2. We're trying to get that L by itself. So we have 200 equals L squared. And if I take the square root, it's going to be the square root of 200. And I'm going to get a decimal approximation for that. So I'm just going to type that in my calculator over here off camera. I'm going to get about 14.14 equals that length. Everything's in feet, so this is going to be in feet. So that's my critical number. If we wanted to confirm that this is the maximum, then we could use that first derivative test. So remember, our derivative was 2 minus 400 over L squared. So that 14.14 is going to go on there. So if I plug in numbers to the left, maybe I plug in a 1. We cannot plug 0 in this case because we can't divide by 0. So we would have 2 minus 400 times divided by 1 squared. And that's definitely a negative value. And if we plug in something bigger than 14.14, maybe we plug in 20. And you can pick any number to the right. 2 minus 400 divided by 20 squared. 20 squared is 400, so this is really 2 minus 1, which is giving us a positive number. And remember, but with the first derivative test, all we care about is the sign. So it's decreasing then increasing. That means this guy has to be a minimum. So now that we know the length, we can find the width. We're going back to our equation here for width. Width was 200 divided by L. So this is going to be 200 divided by the square root of 200, or 200 divided by about 14.14. And we're going to go 14.14. So my dimensions would be 14.14 feet by 14.14 feet. And that minimum perimeter it would be 2 times the length plus 2 times the width. And I got a 56.56. So let's look at another one. Let's look at this one with revenue and profit. We have a company that manufactures and sells digital cameras, X number per week. The price demand equation is 400 minus 0.4x, and the cost equation is 2000 plus 160x. At what price should the company charge for the cameras, and how many cameras should be produced to maximize revenue? I'm copying my equations down here. So we have 400 minus 0.4x and 2000 plus 160x. So revenue is how many cameras you sell times the price. So it's going to be x times 400 minus 0.4x. And we're going to distribute that. So we're going to get 400x minus 0.4x squared. So there's my revenue equation. If I want to maximize revenue, I need to take a derivative. So the derivative of this function is going to be 400 minus 0.8x. And then now we're going to set that derivative equal to 0 to find critical numbers. So we're going to get 500 for that one. We've got 500 cameras that we need to sell. So we can check it by using that first derivative test. This is going to confirm that that's a maximum. Call this right here. So 500 is going to go on there. We need to test to the left and to the right. So if I plug in 0, which is to the left, which I could plug 0 into that derivative. I'm going to have 400 minus 0, which is a positive. So we can see the function's increasing there. And then after 500, maybe I plug in 600. I might get 400 minus 0.8 times 600. And that's going to be a negative value. Negative 80. And once again, we don't care about the number, we just care about the sign. So we're increasing and then we're decreasing, which means that this guy has to be a maximum. So that confirms this is a max. So what is the max revenue? The max revenue, if we plug in 500, Looks like it would be $100,000. Match revenue would be 100,000. And then we need to sell the cameras for some kind of price. Let's figure out what that price is, and that's what that price demand equation is for. So we're going to have 400 minus 0.4 times 500. This is going to tell us the price per camera. Or 200 per camera. So there's our sentence that ties everything together. Part B is looking at maximizing weekly profit. So profit is revenue minus cost. So my revenue is 400x minus 0.4x squared. And we're going to subtract our cost equation, which is 2,000 plus 160x. Remember, this is a capital P. This book uses a lowercase p for price demand. And I'm going to put this in standard order, so decreasing exponents. 400 minus 160, positive 240 minus 2,000. If we want to maximize profit, we need to take the derivative. And then we're going to set that derivative equal to 0. So notice our value is different here. When we tried to maximize revenue, we needed to sell 500, but now we're trying to maximize profit, which is what's left over after we account for the cost, and we're going to sell 300. So once again, we can confirm that this is the maximum by using that first derivative test. So if I were to plug in 0 into that derivative, I would get a positive. So 0 plus 240 is a positive 240. And if I were to plug in something bigger than 300, like 400, I would end up with negative 0.8 times 400 plus 240. And remember, all we care about is the sign. I got negative 80, which would be a negative. So I'm increasing, then decreasing. This is definitely a maximum here. So our max profit, we are going to plug in that 300 into our profit equation. Oops, let me use that one. So we're going to negative 0.4 times 300 squared plus 240 times 300 minus 2,000. Our max profit is going to be 34,000. And let's figure out the price per camera. This is going to go into the price demand equation, and our price demand equation is 400 minus 0.4x. So 400 minus 0.4 times our x. This is going to tell us how much we need to sell each camera for. And it would be 280. So our max revenue, our max profit of 34,000 would occur. We sell 300 cameras at a cost of 280, or at a price. Let's say at a price since that's price demand. It's cost to the consumer per camera. So that's how we do optimization. We figure out the equation that's tied to everything. We take a derivative. We find critical numbers. And then we use that critical number to answer the question.